We must keep in mind that when the Mendeleev developed his periodic table, that time chemists were unaware of the internal structure of atom. The internal structure of atom I already discussed in the previous class, but we have to remember that when Mendeleev develops his periodic table, that time chemists did not know anything about the internal structure of atom. Only in the beginning of the 20th century, that means from the 1900s, that profound developments are witnessed in theories about subatomic particles. That means electron, proton, neutrons discovered from the beginning of the 20th century. So, in the year 1913, Henry Moseley observed the regularities in the characteristics X-ray spectra of the elements. And he plotted the frequency of X-ray emitted against the atomic number. Because by that time already proton, electrons discovered, and number of protons is equal to its atomic number, we know. So on that basis, the Henry Moseley plotted the frequency of X-ray which was emitted from the atoms against the atomic number of the particular element, and which gave a straight line. But if it is the frequency of X-ray emitted, if it is plotted against the atomic mass, it is not the straight line plot. So Moseley showed that the atomic number is a more fundamental property of an element than its atomic mass. Because now we know that atomic mass is the sum of the number of protons and neutrons in nucleus. So number of protons, that means the atomic number, it has the fundamental property of an element, and that's why a straight line has been drawn with the frequency of X-ray emitted against the atomic number. So on that basis, because Mendeleev, we know in his first law, he described the property against the atomic mass. So as per the observation of the Moseley, the modern periodic law stated that the physical properties and chemical properties of the elements are periodic functions of their atomic numbers. And these atomic numbers, we know that atomic numbers is the number of proton or the number of electrons in neutral atoms of a particular element. And this periodic law, this modern periodic law, revealed important analogies among the 94 naturally occurring elements. We know that 94 naturally occurring elements are there, and that means the neptunium and plutonium, like actinium and protactinium, are also found in pitchblende. Pitchblende is the ore of uranium. And with this law, in the inorganic chemistry field, there is interest to carry out the creation of artificially produced short-lived elements. I already told that the atomic number is equal to the nuclear charge, that means the number of protons or the number of the electrons in a neutral atom. And we know from the previous class, that means in unit number 2, that this number of protons or nuclear charge, it is related to the quantum numbers and electronic configurations in periodicity of elements. It is now recognized that the periodic law is essentially the consequence of the periodic variation in electronic configurations, which determine the physical and chemical properties of elements and their compounds. That means the electronic configuration is responsible for the physical and chemical properties of elements and their compounds. And this periodic variation of electronic configurations reflects in the periodic law and in the periodic table, which I am going to discuss now. Numerous forms of periodic table has been devised from time to time. Some forms emphasize chemical reactions and valence, whereas the others stress the electronic configuration of elements. So a modern version, which is called the long form of the periodic tables of the elements, is the most convenient and widely used. So now I'll discuss on the long forms of the periodic table of the elements. This is the long form of the periodic tables containing all elements till now discovered. So this is the horizontal row and this is the vertical column. So the horizontal row, which used to call by the Mendeleev as a series, and the vertical columns, it is the groups. So horizontal line, that means horizontal rows, it is the called as series, and vertical columns, it is called as group. So elements having similar outer electronic configuration in their atoms are arranged in a vertical column, and which is called the groups or families. So extreme left of this periodic table, if you see that lithium, sodium, potassium, rubidium, cesium, these all has the similar outer electronic configurations in their atoms. Regarding electronic configurations, I already discussed in the unit 2 class. So similarly, for the second group from the left side, you can see the beryllium, magnesium, calcium and other elements. They also have similar outer electronic configuration. Shell may be different, but soft shell containing the orbitals, it will have the similar electronic configurations. According to the recommendation of IUPAC, the groups are numbered from 1 to 18. You can see that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And this numbering replaced the older notation, that means 3A, 4A, 1A, 2A, 3A, 4A, 5A, 6A, that this old notation is replaced by the number of groups from 1 to 18. There are altogether 7 periods. You can see that this is the first period, second, third, fourth, fifth, sixth, 7th period. That means group is 18th group and period is 7th period. And this table containing these 18 groups and 7 periods contains all elements. In addition to the lanthanides and actinides, it has a separate table, which also I'll discuss now. And this 7th period, it corresponds to the highest principal number n of the elements in that period. That means there are all 7 periods and the period numbers corresponding to the highest principal quantum number of the elements in that period. That means if it is first period means it is the start with the 1 atomic number. So it is the quantum number will start from the 1. And second period, we know that outer electron configuration 2s1, that means principal quantum number is 2, and 2 means it is the second period, in that way. So the first period contains 2 elements. You see that here first electrons contains only 2 elements, hydrogen and helium. Why hydrogen is placed in middle, that I'll discuss on the next class. Right now, you know that in the first period there is the 2 elements, hydrogen and helium. And if you go for the second period, then you see the 1, 2, 3, 4, 5, 6, 7, 8. And third period also it has 8 elements. And fourth period is 18th, fifth period is 18th, and sixth period is 32, and so on. Whatever you will understand from this, that whatever the number of electrons of the neutral elements in its outer shell, that number is matching with the number of the elements present in that particular period. 7th period, if you see the bottom 7th period, this period is actually incomplete, because this incomplete and like the 6th period would have a theoretical maximum on the basis of the quantum numbers of 32 elements. And here also 6th and 7th, you can see that 6th period, when a lanthanum is there in the group 3, here one star is there. Star means the number of lanthanides elements are there. And in this bottom, whatever table is there, is called the F inner transition elements. Here contains the other elements, which is in the lanthanum groups, and it is called the lanthanide. Similarly, in the 7th period, you see the actinide double star is there. Double star means in down table, you see this is the actinides groups, and these actinoids have number of elements with similar properties. And that's why this both lanthanides and actinides group is called the F inner transition elements. Why F inner transition elements? Because in their electronic structure, outer shell electronic structures, the F electrons are present. So in this form, of the periodic table, 14 elements, both 6th and 7th period, whatever I told, 14, 6th and 7th row, there are the 14th elements, lanthanides and actinides are placed in separate panel at the bottom.